Okay, good evening this time, and we will start a parallel session, evening session for chapter 11. It's not going to be part of the final exam. Chapter 11 is about data acquisition and manipulation. How does the microcontroller acquire data? How does the microcontroller collect data? Okay. In this chapter, we will explore through the data acquisition system in the 16F877A microcontroller that we started covering in chapter 7. Okay, and the main component of this data acquisition system is the analog to digital converter. Okay, we're going to talk about that, the part that's going to be inside the CPU and the conditional circuitry and everything before it. Okay, and how to deal with this data. طيب. In general, why do we need to deal with data in a digital format? Because digital data has many more benefits, advantages over analog data. Some of like in electrical representation. In electrical representation, analog voltage is continuous, while digital is discrete, right? So, if you're dealing with a digital entity, there's a 0, there's a 1, and what's in between them? Nothing. While if it's analog, you will have 0, 0.1, 0.001, an infinite number of variables, right? An infinite number of variables. So digital, it's a disadvantage. It's not continuous. It is discrete. Precision, talking about precision, because in analog, you have infinite number of variables, you have infinite precision, very, very, very precise readings, right? You know exact voltage, 0.0000, theoretically up to infinity. Resistance to signal degradation, however, this is in the favor of the digital format, right? So analog signals degrade with distance, degrade with or get attenuated, distorted, whatever, affected by noise, while digital is more robust in this thing, right? So it's either there or not. If we're talking about a 0 or 1, a digital signal is either a square wave, it's either a square wave or not. There is no attenuated in the middle. In terms of processing digital signals today is very convenient. We have all those computers, microcontrollers, microprocessors. It's so easy. Processing analog data is also there using op amps, right? You can using an op amp, you can do an integrator, you can do an adder, a subtractor, a differentiator, all these things, but still not as digital computers. Okay, in terms of storage of analog signals, mostly it used to be dependent on magnetic tapes, magnetic disks, or these things, and it's limited, always limited. While digital, with the semiconductor memory today, RAM, SSD hard disks, tape, digital clouds, it's in the favor of digital systems. Okay, so there are many benefits. For us, we need to convert data from analog to digital to be able to deal with it in the microcontroller. Okay, and when we talk, let's come back later to these drawings and look at the official stuff. But let me show you the main purpose behind this chapter. When we talk about quantities, هذا microcontroller. This is a microcontroller. MCU صح. We have pins, and we talked that pins, these pins, I/O pins, could be output or could be input, right? Output, output, input, input. In data acquisition, you're collecting, right? You're collecting data. You want to know what's around you. The microcontroller wants to know what is the temperature around it. Is the door open or is the door closed? What's the speed? It's collecting. You want to collect data, okay? So an input signal that comes to a microcontroller, let's agree on this. The nature of the signal, when we talk about an input signal, an input signal is either digital or analog, right? Analog or digital. تفهموا على خطي؟ اوكي.
بس واضح.
واضح.
يلا كويس. Okay, and a signal is either an analog signal or a digital signal. طيب. هلا what do we what is the signal we're talking about in nature of electrical nature? What are we talking about? Are we talking about voltage? Are we talking about current? Are we talking about what?
Voltage.
Talking about voltage, okay? A lot of times we don't say it. Maybe I don't know if you're aware of it or not, but we don't say it. But I say when I ask you what's the input signal, is it an analog signal or a digital signal? I'm talking about voltage here, okay? The signal you recognize on an input pin is a voltage level, okay? Voltage level. ماشي? This is very important. Even لو عندي current sensor, I want to measure a current in a circuit. The current sensor converts the current into voltage, and you read voltage, okay? So the MCU, the microcontroller, is capable of detecting voltage levels. Clear? خلاص؟ هاي مسلمات.
Yes.
مسلمات, okay? So we're talking about. Let's start with digital voltage. So digital signal يعني digital voltage. Okay? What does digital voltage mean? It means that the voltage is either high or low.
0 or 1.
Exactly. Converted into a numeric value, a binary value, 0 or 1, right? So voltage high, all voltage low. The voltage high, we represent it in numbers as a 1. Voltage low, we represent it in numbers as a 0. So binary, okay? And the pins capable of dealing with digital voltage, okay, are the parallel ports, okay, or digital ports. And I told you why parallel, didn't come from here, but it's now خلاص عرف. Parallel ports read digital signals, okay? Digital pins. And as an example on these, we dealt all the time with مثلا a sensor. We used to call a push button. صح? I want to call it a sensor now. It's a push button at the end of the day, right? A push button. You sense if the button is pushed or not. There's a contact or not. So we used to raise it. Oops, sorry. We used to raise it to high voltage, right? To 5 volts مثلا, and take this to ground. And this pin is tied to a data register, right? To a pin مثلا, if this was port B0, then bit 0 in port B register bit 0 will be 1 if the button is not pressed, will be 0 if the button is pressed. تمام لهون؟ Easy, صح? So the voltage is either high or low. nothing in between. And what distinguishes that this voltage is high or low؟ يعني إذا 5 فولت معناته voltage high. 0 volt, voltage low. What's in the between? Well, you remember when we talked about the Schmidt trigger, right? يعني
Yes,
from here
إنه
to
لعند 3 point إشي بيضل هاي.
yeah, يعني في thresholds, okay? So we consider this low, below this voltage threshold low. We call it voltage threshold low. وفي voltage threshold high, right? Above it, خلاص, we consider it volt, يعني 1. Below it, the low 0. In between, we do the hysteresis thing, the Schmidt trigger, right? The Schmidt trigger. يعني I think it is recorded. This was the August.
حكينا عنها بأول محاضرة virtual.
Yeah, يعني it is recorded over there.
Yes.
Okay. So يعني the controller will be يعني إذا جيت أنت جبت voltage هون جبت له voltage من أي voltage source either is 5, 4, 3.7 كله هذا بالنسبة له the same. It's a 1. 0.0, 0.1, 0.2, 0.4, 0.5 هذا بالنسبة له it's a 0. Okay. So binary 0, 1. Clear, right? This is digital signals, digital voltage. Now, this is not going to work in many cases. So imagine you are going to design an embedded system to measure temperature. Temperature. Okay, we have a temperature sensor. Temperature sensor. We'll talk about sensors later, and you already did a search about sensors, right? And in your mini research, and got to know how 10 kinds of sensors work. But many sensors, like most of the temperature sensors, until you power up, you give them power, voltage source, okay, and ground, and you get something called voltage out. You get the voltage level. And this voltage you get from the sensor, the voltage out you get from the sensor is proportional to the actual temperature. يعني مثلا you can say if the voltage temperature, the voltage here you will get from here is something between 0 and 5. تمام? 0 to, let's say, in millivolts, 5,000 millivolts. And this corresponds to 0 Celsius to 100 Celsius. Okay. So it's not going to work to say, okay, if we bring a sensor here and put it on a digital input pin. If I connect this voltage here, I'm going to be able to recognize, to say that the temperature is 1 or 0, صح? لأنه the voltage level is going to be converted into, depending on the thresholds, to 0 or 1, صح? It's a voltage from 0 and 5. زي push button here, like the push button over here. 0 or 5, 0, صح? 0 volt, 5 volt, or any value in between is going to be, according to the thresholds, converted to a 0 and 1. So you will say, okay, your controller will understand this voltage as, it is 0 or it's 100. What about the temperatures in between? You're not going to be able to note that because the pin is digital. So we need, من هون إجا النيد, we need analog pins, analog ports, analog pins, ports, whatever. What does this mean? An analog pin enables you to take a voltage and convert it to a number that is not only one digit. If it's one digit, it's either a 0 or a 1, صح? يعني 0 Celsius or 100 Celsius. right? طيب what if I allowed you to say okay you are allowed to use يعني خليني اخذ هذا الحكي هون هيك. If you are allowed to represent the voltage in one digit, if it's one digit, then you're gonna be able to translate the voltage into 100 Celsius or 0 Celsius, صح؟ يعني two values. طيب if I allowed you to use two digits, two digits is 0 0 0 1 1 0 1 1, then theoretically you can split this range into four ranges, صح? From 0 to 25 Celsius, right? This is 0 0. From 25 to 50 will be 0 1. From 50 to 75 will be 1 0. From 75 to 100 will be 1 1. So I have more precision here, right? More resolution. So the 0 will be 0 0 will be a temperature between 0 to 25 Celsius. This will be from 26 to 50. This will be from 51 to 75. This will be from 76 to 100. But imagine I gave you the liberty to use 3 digits. Then you have how many levels? 2 to the 3, 8, right? You will have, you can, right? 2 to the 3 equals 8 levels. Then you will have more accuracy here, right? If I can split the numbers from 0 to 100 into 8 levels, then the resolution here that was 25 Celsius, right? انت يعني ممكن تكون انت عندك غلط, you may have an error of 25, right? You could be 0 and you may interpret it into 25 or worst case. But if I have 8 levels, then we reduced the error into a half, right? We had double resolution. طيب, if I have 4 bits, then I have 16 levels. I double the resolution more, right? So representing, being able to convert a voltage into and represent it into more digits gives you more accuracy. Understood?
طب دكتور،
Yes.
تقسيمة او اني انا اعطي الديجيتس هاي او اني اعطي الليفلز هاي بتكون موجوده بسبيسيفيكيشنز السنسور نفسه؟ يعني مثلا في سنسورز بتكون الليفلز تبعته يعني هذا الشيء بيكون مكتوب ولا خلص انه انا في مقياس ثاني ممكن اعرف منه الدقه؟
Yes, you are. These are part of يعني the number of digits that can represent a voltage level is one main characteristic of the analog to digital converter. Okay?
Yes, okay. Yes.
The thing that converted this analog physical value into a digital number, this is done by something called A to D, analog to digital converter. تمام?
Yes.
There are A to Ds that can convert a voltage level into 8 bits. There are some that can convert it to 10 bits, 12 bits, and so on. Okay. This is a main feature of one. So you say, I have an A to D, and somebody else says, I have an A to D. What makes your A to D better than his? One of the factors is the resolution, the number of bits. Okay, the number of bits you can use to represent the voltage.
Yes.
Because more bits you have, more resolution you have, more accuracy you have. Okay?
Yes.
Great. So we got the main idea. Okay? This is the main feature. So the chapter name is called Analog to Data Acquisition. Data acquisition, collecting data and to understand the world around you. What is the temperature? What is the humidity? What is open? What is closed? Who moved? All this data. How do we get this data? We get it through sensors. Sensors give us voltage. And the MCU here needs to translate a voltage coming from a sensor that represents a physical value, temperature, harara, into a number. This number will have a meaning then. Yani 0.0001110 will have a meaning that different meaning than 1111111 if it's coming from a temperature sensor. Okay, so you will be able to know what is the temperature outside with high precision, not it's hot or cold. Yani if I put it on a digital import pin, I'll be able to know it's 1 or 0, hot, cold, right? But with more number of digits, you'll have much more meaningful values. Okay, this is the main purpose of a digital analog to digital converter. Okay, so an A to D, A to D converts a voltage. هذا A to D. Well, an A to D, it is usually inside the microcontroller, but you can get an external one. Converts analog voltage into a digital number. Okay, and this digital number يعني if I say في عندي sensor temperature sensor gives me voltage gives me a voltage between 0 and 2000 millivolts, يعني 2 فولت. هذا output V out. And I have an A to D analog to digital converter that takes an input. خلينا بس أسهلها خلاص 5000 خليها 5000 5 فولت يعني. Because why 5? Because it's the voltage source of the controller. The A to D can convert these into a 10-bit number. خلينا نسهلها شوي. 8-bit number. 8-bit number. ماشي? This means that the 0 can be represented. خلينا نكتب hex هلا, okay? 0x00. And the 5000 can be represented as 0xFF. أو بالديسيمال 255 وهذه 0. صح؟ So a 0 Celsius is 0. 100 Celsius is 255. طيب. So you said يعني we connected the A to D. This is the microcontroller. The A to D is here. Okay, there is a register that we can get the 10 bits from. This is a register, or the 8 bits. I have a number here. Let's say 255. Okay, well, the temperature sensor giving me the voltage over here. You can write a program to read this register, and it will tell you that the register value is 255. Then, okay, what's the voltage outside here? Me, who can tell me?
100 degrees.
100.
It is 100. The temperature is 100, but the voltage is 5 volts. Right?
Yes.
Exactly. طيب, if I came here and read the value and it was 128. Well, if it's proportional, linear, then the voltage is 2.5 volts, صح?
Yes.
Then the temperature is then بالنص. إذا ما فيش formula بالعادة بالداتا sheet, the data sheets of a sensor have a formula to convert from voltage to the physical thing you're measuring. Okay, so there will be if your voltage is 2.5, then times x divided by y, whatever, you get the temperature. You get the temperature. Let's say in this case it's 50 Celsius. They're not usually يعني linear, but يعني let's assume. Okay. Got the main idea, guys?
Yes.
So I have a number, and I know how to deal with it in a linear way to convert it into voltage, and if I know the voltage, I can compute the physical thing. If it's a humidity sensor, this number is not going to be Celsius, but I'll still read voltage. And the data sheet of that humidity sensor will give me the formula how to convert this voltage to humidity, okay? Or this voltage into a distance, whatever. Great. The more bits you have, in this case, our A to D used 8-bit number. تمام؟ انتبهوا لي ترى أنا قاعد بشرح هون. When we go back to our slides, you'll find that we moved a lot, okay? So one of the main characteristics of analog to digital converter A to D, مرات بكتبوه ADC, analog to digital converter, or analog to digital converter, أو مرات بكتبوه A to D هيك. تمام. One of the main characteristic of the A to D is the number of bits it can produce from converting. So هذا A to D, it gets an analog voltage and it gives n bit digital number. Okay, and what happens here is magic. Well, it's not magic. I'll talk about it, but not in details because we cover it in the graduate level. Magic. So if I get here, if my n is 8, معناته I can represent the voltage in 2 to the 8 levels. صح؟ 256 levels. صح؟ اللي هم من 0 ل 255. طيب if n was 10 معناته I can exactly I can cover it. I have 2 to the 10 levels, right? And this is 1024 levels اللي هم from 0 to 1023. Imagine this voltage. Imagine this voltage is something between 0 to 5 volts. خلينا نحاول نفهم. If my 0 to 5 volts is a 5 volt range, صح؟ يعني 5.0 is 5. So let's say talk 5,000 millivolts. If I am to divide them to 256 levels, this is equal to what? I think it's 19.5 something millivolts. While if you divide 5,000 millivolts by 1024, this is about 4.88 millivolts. See? So more bits represent that. This is called step size, or sometimes they call it resolution. So a 10-bit A to D, صرنا نحكي هون 10-bit A to D will give me 4.88 millivolt resolution or step size, while an 8-bit A to D will give me 19.5 millivolt step size or resolution. Okay, sometimes resolution is used for the physical meaning. So 19.5 millivolts is dividing this range, right? But this range measures مثلا values من ناقص 40 Celsius to 120 Celsius. Okay, وفي formula. So كل 19.5 millivolts قديش قسمهم؟ مثلا بتطلع 1.1 Celsius مثلا. While this one, I can measure less voltage, معناته this is almost 1/4 صح؟ يعني ربع هاي. It will be like إذا كانت هاي 1 Celsius, this will be like 1.25 Celsius. So you got more accuracy here. تمام؟ تمام.
Yes.
So what we were talking about is what happens over here, right? We get a voltage and then we get a digital output. تمام? And this thing here, actually let me draw this line. شايفين هذا السكوير؟
دكتور بس ممكن سؤال على
تفضل يا قيس.
ملي فولت. هلا مين اللي فيه ايرور اقل 5 ملي فولت ولا 20؟ 5 صح؟ ادق لانه
error أقل.
يس
Yes, it's more precise. It has higher precision, right? You can, يعني instead of telling me that الحرارة is either 1 Celsius or 2 Celsius, you can tell me it's 1.25 Celsius or 1.5 Celsius. You have more precision.
يس
دكتور
Yes.
بس اوكي بصير عندك accuracy احسن بس انه ممكن بصير لانه الستيب قليل 5 ملي فولت فممكن بالغلط تطلع انه من النويز تطلع عليه او يعني تقرا تعطي قراءه غلط لانه ستيب قليل اما 20 كبير فالايرور ممكن يكون اقل.
You're talking about noise. Noise, yeah, may affect smaller. صح يعني more يعني إذا if my signal is 2 millivolts يعني I have noise in the بالجو أكثر من هيك صح؟ So yes, you're right. However, you can deal with this. يعني خلينا أكمل هذا اللي بحكيه. You're right. بس is this noise you're talking about gonna be worse than reading a more accurate value؟ يعني إذا بدك تخربط هون بتخربط لك بربع درجة ثانية. نص درجة. While here you're either 1 or 2 or 3. هون you're 1, 1.25, 1.5, 1.75, 2. See how many you have 4 steps and you have 4 times accuracy here. So you're right. يعني 4 millivolts can be affected more by noise if compared with the 19.5 millivolts, but still it has the يعني more accuracy. طيب. Now this is a typical data acquisition system. ماشي. This inside the red box is usually inside the microcontroller. Well, at least in our 16F877A controller, this is inside the microcontroller. تمام. While this part is outside. This is what you do to prepare and interface your transducer or sensor. Okay, so a typical data acquisition system has transducers or sensors. Okay, why did you call it a transducer? Because it translates or transduces or converts a physical value like temperature, like humidity, like distance, okay, into an electric signal. And this is the area of, I don't know, sometimes chemistry people, physics people, you know, a temperature sensor, what is it? It's some kind of material that its characteristics change depending on the temperature around it. So if you feed it some voltage, you get a different voltage as in the output depending on the temperature. And you can find a relation between them, and that's a temperature sensor. Same for humidity, same, okay? So people who work in sensors, who make these kind of sensors are not us electrical engineers. It's the people who deal with lower level of material. But okay, you have a sensor. And a sensor, I personally dealt with sensors that give you 1 millivolt. Well, this 1 millivolt, if we're talking about the 10-bit the 10-bit A to D I was talking about right now, is able to recognize 4.88 millivolts, right? So this is much lower than it can recognize. So the signal you take, you need to do some signal conditioning. We call these steps here signal conditioning. Signal conditioning. Okay? Signal conditioning involves amplifying the signal. Well, and the voltage you can read here is positive voltage. So if you were in the negative part, you may need to add an offset or flip it. Okay. Then the signal could be, when you amplified it, you may have amplified some noise with it if it was so small. You may need a low pass filter, averaging filter, which is a low pass filter, of course, any kind of other filters. You need to filter it to make sure, yani getting the responsibility of getting the clean signal before input, connecting it to the microcontroller, is the responsibility of the embedded system designer, you guys. Okay? Now, these are the things you study in electronics, right? Circuits, signals, and systems. You know how to do filters, amplifiers, offset circuits, etc. Signal conditioning. It's not our topic here, but I'll point to some places where you need it. One of the main features, usually you should be able to use an op-amp circuit to do a simple amplifier. Okay, a filter, a simple low-pass filter, or the filtering could happen maybe inside on the digital number itself. And if you're reading something, but then if spikes every, you're reading 128, 128, 128, you're reading the sensor, but then suddenly you get 200 spike. Well, and averaging, reading every, مثلا كل 5 readings, you average them. This is a type of low pass filter, right? You get rid of these kind of spikes. Anyways, then here comes our pins. This ADC, this analog digital converter, is a very expensive equipment. This is very expensive. طيب. So an analog to digital converter, if you remember in chapter 2, when we talked about our microcontroller, the 77A microcontroller, this one, where is it? We said, and I talked about this long time when we were talking here, this microcontroller has 8 10-bit ADC. ال8 تعود على channels, okay, 8 channels. Resolution is okay. Resolution is 10 bits. ماشي? So the 10 bits we were talking about. The 8 is the number of channels, يعني 8 pins. You can connect 8 sensors. تمام? So this is our 16F877A controller we're dealing with. And these pins, we're gonna talk about it. We started this in chapter 7, that's still running. We have 8 channels. These are 16F877A controller has one port A اللي هو من RA0 to RA4, right? هذول 5 bits, 5 pins. في عندي port E 0 port E1, port E2. 5 plus 3 equals 8 channels. Okay? Port A0 now is called AN0 slash. Yani you can configure this pin as a digital pin and call it port A, or analog pin and call it analog pin 0. Same for everything else. So 3 pins on port E, 5 pins on port A. These are 8 channels. Okay? So the 16F877A controller has 8 channels. 8 channels that you can connect 8 sensors. Sensor 1, sensor 2, etc. 8 sensors. Hala, inside, I have only one A to D. تمام؟ ما عنديش 8 A to Ds، يعني مش كل واحد من هذول واصل على A to D. They are all connected through a multiplexer. هون selector هذا. Something you can switch, which is presented better than my drawing in this slide. وينه؟ Here. خلينا ننظف السلايد بس شوي. How do I erase? Okay. So the 8 pins we have, اللي هم هذول. See? 1, 1, 2, 3, 4, 5, 6. We have 8 channels. We cannot afford to have 8 ADCs. We cannot afford to have 8 analog to digital converters. We only have 1. There's a multiplexer here that selects what channel, what sensor you want to read. I want to read the sensor connected to AN0 on port A0, the one on port A2, the one on port A3. You select here. We have the control to select. ماشي? To save ADCs. Clear so far? And يعني here we control the switching here, the multiplexer, through registers inside. طيب في CPU control that selects. طيب. No questions. Then we have a sample and hold circuit. Sample and hold circuit. I'll talk about it. Then we hand the value to the ADC. We get a digital number in a register, and then we deal with it. طيب. بس أنا هذا بدي أفرجيكم إياه. خليني أشرحها. طيب. This is the analog to digital converter, and by the way, you can buy a chip, an external ADC converter. You have an analog signal here, and you need to produce a digital number. Okay, this analog input I have here to be able to convert it into a digital number. Imagine I have this analog signal, linear. طيب. How do I convert it? This is the voltage. And this is the digital number of digital output. The one we're going to get over here. The maximum, the biggest digital number I can get is what? Depends on the resolution. On if this is a 10-bit ADC, then the maximum is 2 to the n minus 1. يعني يصير أنا أقيس من 0 to n minus 1. If we were at 10-bit, then this is 1023 صح? If we were 8-bit, then this is 255. okay, and the voltage مثلا من 0 to 5 volts. خليني أكتب بالأسود. Now, when you convert an analog value to a digital value, the analog value, we have infinite number of analog values, right? So you cannot convert everything, it's infinite. So you need to take samples. Darsin sampling theory?
Yes.
Okay, so you take samples. So you can take a sample over here. This is how we start to convert. We take a sample over here, we take a sample over here, we take a sample over here, sample, samples, sample. And to be able to recover the original signal, your sampling rate has to be
Double.
more than 2 times the original frequency, right? And we call this
Yes, Nyquist rate.
Nyquist law.
Nyquist
صح? Thank you. يلا تبين. Good job. So here we connect everything together, control my signals, my electronics. Okay. So you take a sample. Now, at any point of time, if the microcontroller wants to learn what is the signal outside, if that point of time is here, then I know it, right? So let's assume we're talking about 8-bit microcontroller. Then the maximum value over here is 255. So then these are 0, 1, 2, 3, 4, up to 255. يعني انت in binary 8 zeros صح؟ بعدين 1 2, the 2 is 0 1 and so on. آخر شيء 255 is 8 ones, right? Okay. The voltage you can recognize for reading is how much? Yani if I read the 255, let's say our max is 5 volts. Or 5,000 millivolts. Then a 255 translates into 5,000 millivolts, right? طيب, each step over here translates into how many volts? Easy, 5,000 millivolts, right? Divided by 256 equals 19.5 millivolts, right? So إذا أنا قريت the reading was 0, then the voltage is 0. If the reading was 1, the voltage is 19.5 millivolts. If it was 2, then the voltage outside is 2 times 19.5. 4 times 19.5. Okay? طيب. What about the values in the middle?
Quantization.
Quantization. Thank you very much. The quantization. So a 0 will stay a 0 until the next sample here. Now it's a 1, stays a 1 until we get the 2, 2 until we get the 3. We do the quantization. Hello, what does this quantization? How does this happen? Using the sample and hold circuit. Sample, you sample, hold the value you sampled until you hold it until the next sample. You hold it until the next sample. You hold it until the next sample. Okay? That's why we need a sample and hold circuit. اللي هي هاي. Sample and hold. Okay? We're going to look into it more, a little forward. Then the value you hold it, you sampled here, you give it to the analog to digital converter. It converts it into a digital number. If it was an 10-bit ADC, you get a 10-bit digital number. If it was an 8-bit ADC, you get an 8-bit digital number. Okay? in some register. Now, what happens inside here? You can do the conversion from analog, from this sample voltage into a digital number using different ways. One way is called مثلا الفلاش. يعني analog to digital converters يعني are many types. يعني their task is non-trivial. في شغل بصير. Okay. For us as embedded designers, we need to know the ADC characteristics, but we don't really need to know what's going on inside the ADC. في dual ramp ADCs, في flash converter ADCs, في successive approximation ADC, وهذا the most common, وهذا is the one used in this microcontroller. Successive approximation. In general مش راح اشرحه بس باخذ voltage, okay, analog voltage, بعدين بيجي باخذ الفولتج رينج المسموح فيه من 0 ل 5 ببلش فيهم بقول بيجي على النص 2.5 فولت باخذها على ديجيتال على انالوج تو على ديجيتال تو انالوج كونفرتر. Did you ever hear of analog to digital to analog converter؟ احنا اللي بنشرحه ايش هو؟
analog to digital.
analog to digital. طيب did you ever hear of the digital to analog؟ يعني what we're talking about احنا this course is this chapter is about A to D. بس في شيء اسمه D to A, digital to analog. بدهوش chapter مش محرز. Our microcontroller does not have a D to A. Most of microcontrollers do not have the D to A. You have a digital number. What does this translate into volts? العكس يعني. هلا you can get a chip called D to A. You give it a number, it gives you a voltage. So it's an output, يعني kind of. A to D input to the microcontroller. You sense voltage, translate it into a number. The D to A, you give a number to this device, it gives you a voltage output.
Yes, بيكون من resistors.
Okay, yeah, the ladder resistor A to D, دارسينها somewhere?
Digital electronics.
Great, خلص, I don't have to cover it. تمام. Yeah, it's not part of this, but I was going to point to the ladder resistor D to A. It's easy, and you can get a bunch of resistors, connect them in a way, give them zeros and ones, and you get a voltage. So that's easy. So part of the successive approximation, when kunna here, approximation, BG, okay. The voltages I'm expecting is something between 0 and 5, صح? 0 and 5 volts. So you go to the middle. 2.5 volt, you convert it into a number. Okay? Well, you give a number 128. 0.00011, صح? أو 1.00000. Convert it into a voltage. بعدين تدخل على voltage comparator. You compare the voltage you produced مع الفولتج اللي you read from outside. If they match معناته هاي الريدنج تاعتك هاي 10 bits or 8 bits. If they don't match, if it's larger بنروح we jump بنروح على النص الفوقاني. It's larger than 128 بنروح على النص بين 128 و 255 the middle ناخذ الميدل. بنرد نقارن. Is it equal? No, it's not equal. طيب أعلى ولا أقل؟ If it's أقل بناخذ صارنا بين ال 128 و 250 والنص هذا. Approximation بيظل يقرب until he finds the number. So slower, well يعني not that slow, it's medium speed, it's considered medium speed with medium accuracy. This is the most common A to D analog to digital converter. This is all what you need to know at this point. طيب ADCs, when I say I have an ADC, you have an ADC. Is mine better than yours or what? We need to know the characteristics of the converter. يعني conversion speed, how fast, يعني since you get the voltage until you get the number. When you read the voltage until you get the number, how much time is going to take? Conversion speed. بعدين accuracy, the step size, اللي هو resolution that we were talking about. Is it 10-bit A to D? Is it 8-bit to A to D? Is it 12-bit to A to D? Because this converts into 4.8 volts, millivolts, or 19.5 millivolts. If it's 12 we're talking about more precise than speed, step size or resolution, and the interfaces. Okay. So we're going to talk about these. This is what we were talking about right now. Voltage ranges كمان هو موضوع. So the minimum voltage you can recognize, the maximum voltage you can recognize. The input range هذا بنسميه. Usually it's the voltage range of the microcontroller يعني من 0 ل 5 if it was 0 ل 5. Then the number of bits that represent the output, if it's مثلا 10 bit A to D, 10 bit A to D معناته you have numbers from 0 to 2 to the power 10 minus 1 يعني ل 1023 صح؟ وقسم بيناتهم. Now this is called the step size. The step size is the amount of voltage that needs to be in يعني that could be sensed to be able to move from a number to the next number. وقلنا this is called computed like this. Step size equals voltage range,
number of levels.
voltage range divided by 2
levels
levels اللي هو ايش؟ 2 to the power
2
n.
to the power n.
يعني في هاي الحالة if this voltage max was 5 volts then it is 5000 millivolts divided by 2 to the power n في هاي الحالة is 10 على 1024 and it is equals to 42.88 millivolts. Then this step size to move from one reading to another reading is 4.88 millivolts. The sample and hold holds the value holds the value ليش صار هيك؟ Okay, holds the value of the voltage you read in a sample until you get another sample. طيب, anything else? Okay, let's move. Conversion characteristic, input voltage. We talked about it. The voltage you can recognize from 0 to 5 or 0 to 3 or whatever. Output values. You can represent depending on your A to D how many bits. So if it's 10, yeah, and it's 2 to the power 10. So from 0 to 2 to the power 10 to n minus 1. Okay. Input ranges, the output, if it's 8-bit, then you get 8-bit numbers. If it's 10-bit, you get, if it's 10-bit, if this was 10-bit, هاي في حالة ال 8-bit. طيب, if it's, I'm gonna get from 0 to FF. طيب, if it's 10-bit, I'm gonna get from 0x 00 to how much?
3FF.
0x 3FF. صح؟ يعني 10 ones. Thank you. تمام. هذا اللي حكيناها. هاي step size. نظري conversion speed في سرعة. How fast you can get a number that represents a voltage. بس بجميع الأحوال to be able to recover a signal you need to consider Nyquist's law اللي هو صح you need sampling rate احنا and this is something we control how fast we can sample. طيب. That is at least twice the frequency of the signal you're converting. The digital interfaces, I'm going to come to this in details. The interfaces, how we control the A to D, what are the interfaces, how do we connect the signals, the voltage references. I'll do them by example. It will be easier. There's something, طبعا signal conditioning. I talked about this. It's not the main issue. Signal conditioning is this part that you do over here. هذا signal conditioning, okay? The signal you get from a sensor could be very small. You need to amplify it. Part of it could be negative. You need to add an offset, a positive offset, okay? It could have some noise. You need to use a filter. These processes you do here is called signal conditioning. طيب. So you need to do signal conditioning, like amplification, filtering, and I يعني هسه يعني جبت شوية هيك أشياء مفيدة. I'll come to them. Signal conditioning. الvoltage range طبعا we assumed here, so the step size here إذا كان voltage from 0 volt to 5. We computed from 0. So step size is 2 to voltage range over the number of levels 2 to the n, right? وهذا مش حفظ يعني if we go here and I say I can recognize a voltage from 0 to 5,000 volts, millivolts. Voltage low, voltage high. And I have a 10-bit A to D. Then the smallest number digital value is 0. The largest is 1023. طيب you wrote a program that converts into an A to D. This is what you read. بالنهاية this is what you read inside your program. And you said read the A to D. Read the voltage on pin number port A0. You're gonna read a number here. Let's say 512. 512 شو يعني الفولتج برا؟ You need to know it to be able to convert voltage to temperature من الداتا sheet. How do we compute it? شو بسموه عندكم؟ يعني هي بالنص هون جايه ال 512. بس how do you compute it؟ يعني if I know X, I know the reading here. Let's call it voltage VK. أنا بدي أنتقل للخطوة دي. The أو مش VK, K يعني a number. Let's assume this is called K. K was 512. What is the voltage that corresponds اللي واصلة على البin that corresponds to this number? This is the unknown for the microcontroller. This is the known. You know it. في voltage connected to the pin. You say read the analog voltage on pin number X. You get a number. طيب. Then you need to do the math inside your program to be able to know what is the voltage outside. The voltage VK. VK equals what?
الريزوليوشن مضروب في الليفل.
512
resolution مضروب في الرقم صح؟ لأنه أنا I know the step size. This is something. Okay, step size اللي هو ال 5000 صح؟ تقسيم 2 أس 10,024 صح؟
24.
And this is 19.5 milli volt. So أنا عندي 512 ضرب 19. Exactly, that's correct.
دكتور مش هون كانت 4.88 مش 19. 19
sorry 4.88 هذاك ال 8 bit. Yes. So you can say شو بسموه انتم ضرب تبادلي صح؟
Yes.
So yeah. So the value is, if I know K, يعني اللي هي 512.
سوري في كي بتساوي 512 ضرب 5000 على 1023.
So you can do it like this, again بالله.
512 ضرب 5000 على 1023.
Yeah, this is it. ضرب 1024. And this is the step size, صح؟ صح؟ بس in another way انت في ريشيو هون، يعني هاي is يعني the reading you read 512 على 1000 sorry 23 here 1023 ضرب I want to convert it into a number related لل 5000. So هاي assume it's K. إذا K كانت 512 على 1023 نصها، نص ال 5000 نص في times 5000 بكون 2500 ملي فولت صح؟ طيب if the reading was 1023 over 1023 this is 1 times of 5000 equals 5000. If it was 0 0 over 1023 يعني ضرب تبادلي صح؟ يعني this is a ratio هاي على هاي ضرب القيمة اللي بدك تاخذها. Okay, or the step size. The step size ضرب number of steps, whatever. Well, this is assuming we're counting from 0. But if we're counting إذا كان الفولتج reference في voltage reference low غير الصفر, there's a you can compute it this way. طيب A to D converters are ratiometric. They call them ratiometric, which means that the reading you get relates to the voltage analog input voltage low and analog input voltage high. يعني if the voltage levels يعني voltage reference, if the voltage reference يعني in other words this is voltage reference low and this is voltage reference high. Voltage reference 0, voltage reference 5000. طيب if this was 1000 you can, and we have the ability to change it, then the 512 is not 2500 anymore. ليش؟ لأنه zero is going to be 1000. Zero is 1000 now. صح? So the reading you get depends on the voltage references. And this is one important characteristic of an A to D. What are the voltage references that you can deal with? طيب. Usually they are 0 and VDD, the voltage, the high voltage of them, the controller. But sometimes you can have a voltage reference that is different. طيب. في هاي الحالة الvoltage that you read هو this is what we wrote صح؟ هو الريدنج اللي قرأته ضرب هاي بالعكس. This is the K, the voltage outside اللي what we did over here, right? هذا هو. The voltage is the reading if this is K ضرب ألف على 1023 and this is here. اوكي انا فاتح السلايد مرتين يعني شو اللي قاعد يصير. اوكي هاي الفولتج outside is the reading you read على هلا VK. what is VK here؟
دكتور هي
ترى معكوسة هاي صح؟ input will be converted digital code. هاي العكس، هاي digital code إذا عندك الفولتج. بس إذا أنا عندي digital code بدي أحسب الفولتج هذا this is it right؟ this is the, يعني افرض الفولتج reference تاعنا كان 0 صح؟ so you can take this out. then الفولتج اللي حسبناه احنا قبل شوي was this وهذا الرينج was 5000 صح؟ الرينج was 5000 ضرب 512 اللي هي الكي صح؟ على 2 اس ان ناقص 1 اللي هي 1023. Okay, so this is the same equation we had, but it considers if you have voltage reference low other than 0 that you can add it in this case. في هاي الحالة الرينج بصير ال V reference high minus V reference low. So يعني لو كان عندي V reference low 1 volt V reference high 5 volts, okay, and you read K was 512. When this was 0, you know that 512 translated into 2.5 volts صح؟ بس لما صارت هاي 1 how does it translate into؟ بتصير
1000
voltage reference low 1 plus شو اللي صار؟ 1 plus range 5 ناقص 1 4 صح؟ اللي هي 4000 ملي فولت times 512 over what? 2 اللي هي 1023 and you compute it.
1000 مش 1.
1000 yes 1000 millivolts yes okay and you compute it. لما كانت 0 هذا ما كانش البارت موجود وهي كانت 5000. اوكي المهم نكون فاهمين هاي امثله examples you can بس تطبيق مباشر اذا الفولتج ريفرنس هيك low high قديش الرينج 10 bit A to D هاي امثله you can look at them. For the signal conditioning these are very simple and يعني very useful circuits you can use. يعني if you have a very small signal you want to amplify it a simple amplifier دارسين is it in electronics or where do you study these things?
Electronics.
741 op amp
Yes.
huh?
Electronics.
Yeah 741 op amp simple as this with changing the values of R2 and R1 you can change the gain صح؟ So إذا كان عندي الvoltage coming is very 1 أو 10 millivolts وبدي I want to amplify it the voltage لأنه 1 millivolts ولا 10 millivolts يعني شو 2 steps يا دوب يقدروا يميزوهم صح؟ بس لو بصير أكبر you can recognize them. بعدين افرض أنت عندك this is another important thing ركزوا لي معي والله شوي. هذا مايكرو كنترولر MCU وفي بورت A وهون في ال ATD. هذا الفولتج ريفرنس تاعه voltage reference high is 5 volts والvoltage reference تاعه low is 0 volts. اجاني temperature sensor that gives me a voltage V out that ranges from 0 volts to 2 volts. You know what this means? This means if I have a voltage coming from a sensor into an A to D that covers from 0 to 5 volts, يعني voltage reference low, voltage reference high, this is capable, this A to D is capable to converting the voltage between a number of 0 to 1023 إذا كان 10 bit A to D. بس أنت what's happening here? Your voltage is 2 volts maximum. So أنت هون يعني 2.5 is 512 صح؟ You're around somewhere here يعني والله you can do the math يعني 2000 volts إذا الستep size عندي هون كم إحنا؟ 4.8 صح؟ ل 1023 so if I do a يعني 2000 millivolts هذا الماكسيمم كم ستيب عندي اذا الستيب is 4.88 then 409 then the maximum is 409 so you're using only this part of the A to D هذا كلياته unused. What does this mean? If you convert this into temperature, the temperature step size انت افرض معامل temperature equals x times I don't know coefficient y على الفولتج او ضرب الفولتج اللي you get here او ال k هذا. الان الرينج هذا is waste يعني انت التمبريتشر 4.88 ملي فولت ممكن يكونوا نص درجه يغطوا لك اذا هذا بقيس بين 0 و 400 درجه. But if you amplify the signal here ضرب 2 تعملها من 0 ل 4 فولت then you use more steps صح؟ then you will have more resolution in measuring your temperature. Okay, so يعني an amplifier is useful مش بس عشان نكبر signal صغيرة. It's useful to amplify a signal to maximize the coverage of the voltage range that the A to D can understand, to get a better, more precise physical value you may want to sense. المهم, this is a very simple amplifier. This is a voltage translation circuit that is capable of amplifying and doing an offset. 2741 يعني هاي الفاينل voltage output you get here is the voltage input you get times RF over R1, and this is the amplification part. صح؟ وهذا الاوفست part. يعني connect to V1 هون negative voltage بصير زائد، وهاي الفاليو RF على R2. You can shift the signal لفوق صح؟ You can add. You can add a positive offset or a negative offset. إذا كان voltage you get from your sensor مثلا is something between 3 and 7 volts. بدك negative offset صح؟ تنزلها شوي. فهون بحط positive voltage. إذا كان بالنيجاتيف you need to offset it to bring it over zero. Simple circuit. All you need to play with these resistors. Some examples. Okay, and this multiplexer now. This multiplexer is something we program and we tell it go select, go connect to our sample and hold and ADC circuit, connect the A to D to port A0 or 1 or 2, okay, multiplexer. And this has control inside any of the registers we're going to deal with. هلا هذه sample and hold circuit. هلا all the things this multiplexer والفلترز والاشياء اللي قبليها have an equivalent resistance. لهم equivalent resistance. طيب. Sample and hold, it's like you sample, you close the switch, هذا الكاباسيتور starts charging to get to a value. But because the signal source اللي coming in مع all those layers of amplification, offsetting, filtering, multiplexer, في لهم equivalent resistor. So we have an RC circuit here. So this causes, طبعا we have the control to switch the sample and hold on and off. But the RC circuit will cause, this voltage cannot raise to the value of the actual signal in zero time, right? But في لها rising time. It's going to take time. صح? It can't just go jump in zero time and become the actual sample. ففي some delay because of this RC circuit. But then this buffer will take the output to the A to D مباشرة. لكن so هنا there's something we need to work on here, the timing. How much do we need to keep this switch closed and charging the capacitor? Knowing that, أنت usually to get to the 100% signal, you need some time. But getting to 0.9 of this signal value, you need half of that time. So you can correct for it. And this is what أنا مش شايف ترى هون أنتوا شايفين تحت التاسك بار مغطي عندي. Okay, I cannot see it. But I'm not gonna spend a lot of time here. So usually the acquisition time that can be computed using this formula, and it depends on the R and C. Usually you get to the 100% in 7.6 RC time, while ممكن تصل ل 90% 90% of the signal in half of this time 2.3 RC. شوف قديش في فرق. And this is what is usually done. Because, and it's an optimization, yani you don't want to close this too long to get to the maximum charge and slow down the sampling. لأنه in this case you cannot sample high frequency signals. And you cannot do the switching real quick وما يلحق يشحن. Okay, so some reasonable time is around this 90% of the signal. طيب كيف بيشتغل هذا ال A2D؟ بعدكم هون انتوا ولا روحتوا؟
موجودين دكتور.
معك دكتور.
Yes, دكتور.
Okay. So the whole operation كيف تشتغل؟ We configure our ADC. هذا هسه راح نعمل مثال. طيب هسه راح نعمله مع بعض. We configure it بنقول له choose this channel. This is the timing we want to work with. This is the channel we want to read. The result, put it in these registers this way, and we do the math and figure out what was the voltage outside. Okay, so we select the multiplexer, tell the multiplexer where is the sample signal we want to read, where is the sensor connected to, بعدين start acquisition, delay the signal acquisition because لأنه في minimum amount of time between هاي السيجنال راح تقراها, the one you read right now and the one you did before. Okay, في minimum amount of time for the A2D to be ready. Sample, hold it for amount of time. قديش I don't want to hold it too long عشان أبطئ العملية ولا too short بحيث I don't get an accurate signal. Okay, بعدين start conversion, start the successive approximation. هذا takes some time. So we need to wait for a flag to raise and tell us, نعمل delay هون, to tell us the conversion is done because the successive approximation, as a quick idea I told you about right now, راح يقارن مع رقم. If it's higher or lower, then he goes to another number, check if it's higher or lower. Lower. You call it binary search into your computer engineering, guys. It's like a binary search, صح? But then you read the data. And so on. This is simple, quick, and I just got an SMS if I want قطايف. For me. طيب. So let's do an example. شو رأيكم؟ بس قبل الexample. These are our signals. These are, احنا حكينا we have 8 channels, right? The 8 channels are port A0, analog 0. Analog channel 1 is connected or shared with port A1. Analog channel 2 with port A2. Analog channel 3 with port A3. Analog channel 4 with port A5. ماشي؟ مركزين؟ ما فيش port A4. بعدين analog channel 5 with port A0. 6 with port E1, 7 with port E2. But then if we have 3 bits here, this is the multiplexer. This is the multiplexer. Multiplexer we saw over here. This one. طيب. So we set 3 bits to select what channel we want to read. تمام? As a voltage input على A to D, and we have some controls here, 4 bits, to select our voltage reference high and voltage reference low. لأنه هذول very important because if it's 0, قلنا it's ratiometric. The reading you get from here, the 512 that you get from here, مثلا, it translates into a different voltage if this was 0 and this was 5. Well, this was 1 or 2 and this was 5. صح? So we have the option to select the voltage references to be the voltage source and ground of the microcontroller, and we can switch it and connect it to 2 pins اللي هم هذول port A3 and port A2. هون بقدر أجيب voltage reference external, أحط أي voltage خارجيين, والnumber that I'm gonna get here is relates or ratio relevant to these references. So the references can be the voltage the voltage source you use for your microcontroller or something external. طيب. Let's talk about the registers. I think we're going to finish this today and do a good example. The registers we're going to deal with هم 4 registers. ADCON 0, ADCON 1. These are configuration registers. وين موجودين؟ في الرام, special function registers in the data memory. We configure them, we pick the channel, we do the conversion speed, all these things. طبعا we need to configure port A and port E. في port A TRISA و port E as input لأنه الانالوج to digital we need to input صح عشان buffer to enable us to input the voltage. So هذول by default. بعدين عندي ADCON 0, ADCON 1. بعدين A to D will start converting this to a digital number, then we get a result. The result we find it in AD result low, AD result high. ليش 2 registers للresult? Because it's 10 bits صح? So and all our registers are 8 bits, so no one can يعني ما فيش 8 bit register. We need 2 registers to hold the 10 bits. Okay? Let's look at these registers, ADCON 0, ADCON 1 now, real quick. ADCON 0, first of all, we have a power bit. هذا. Usually, the A to D, the analog digital converter is powered off. في له circuits جوا, صح? في comparators وفي things, في له power. To save power, if you're not using it, you switch it off. When you want to convert, you switch the analog digital converter on by writing this bit to 1. Okay? Simple. Bit number 1 not used. Bit number 2. This is a bit we write and we read. كيف؟ خلاص you did your setting, you selected the channels, everything. You want to read the voltage outside from the sensor. You go write a 1 here. You say go. شايفين? Go. You write a 1. The conversion will start. ببلش يشتغل works until we get a number. How do we know that the conversion is complete and we're done? This bit, I write a 1, and I wait for it to become back a 0, to go back to 0. When it's back to 0, then we're done. Okay? This is one way. If we want to do it using pulling. So if I want to do analog to digital, I want to read the temperature sensor value. I come to this bit, I write a 1 here, and then say, while this is still 1, keep waiting until it's 0, then your reading is ready, go get it from the result resistor. This is one way to do it. There is another way, we check for the interrupt flag for the A to D. طيب هلا الانتربت flags والinterrupt enables لسه ما درسنا, we're working on them in chapter 7 tomorrow morning يعني, okay? Then we have these 3 bits are the channel select 0, channel select 1, channel select 2 اللي هم هذول شايفينهم 3 bits. If I write 1 1 1 1, then I want to read the sensor on port E2. If I make them 0 0 0, then I want to read the sensor on port A0. Okay? هذولا, these are the channel select bits. هيهم. Bits 3 to 5. 0 0 0, channel 0, analog 0. 1 1 1, analog 7. طيب. بعدين في I have 3 more bits اللي هم analog to digital. شو اللي صار؟ كيف هي صارت؟ والله حلوة بس I don't know how. Analog to digital clock select 0, analog to digital clock select 1, في analog to digital clock select 2. شايفينها هاي؟ بس هاي وين موجودة بالريجستر اللي اسمها ADCON 1 اللي هي هاي ADCON 1 هذا البت. So this bit in ADCON 1 هاي ال ADCON 1 register مع هذول ال 2 bits من ال ADCON 0 3 bits هيهم. They select the clock conversion speed, the frequency that will be used for the A to D. تمام? So we can use the oscillator frequency divided by 2, by 8, by 32, by 4, by 16, by 64, or we can choose an RC clock. Okay? في RC clock غير الoscillator. طيب. What is the right frequency? We'll look at it. اخر شوي. بس using these 3 bits, we select the frequency. 2 bits of these three are in ADCon 0 here اللي هم هذول، وفي هذا البت بالADCon 1 اللي هي النكست بيج هذا. اوكي؟ هذا نفس التيبل. With the other two bits we select the clock convergence speed. طيب في 4 bits هذول. These 4 bits are هذول شايفينهم هذول 4 bits. هذول 4 bits. Part of their work is to select the voltage reference high and low. هل هم راح يكون الفولتج source تاع المايكرو كنترولر or something external. And the pins port E of port A and port E, are they gonna be analog or digital? طيب question mark. الديفولت إذا تتذكروا when I was using this microcontroller I said this last time, I never use port A. I never used port A because these bits are usually default تاعهم are zeros. And look at this. Port A هيهم port A. Port A0 اللي هي AN0, AN1, AN2, AN3 and AN4 ها؟ من 0 to 4 هذول port A. الديفولت تاعهم analog. See? So I was not able to use them like port B and port C. To make them digital, and we're going to do this in next time chapter 7 يعني ها? I need to make these 4 bits 0, 1, 1, 1 or 0 to make all port A and port E digital. هذول port E. هذول port E, هذول port A. هذول port E. ماشي؟ Default for port A and port E are analog, but if you want to convert them to digital, you can do this. You write as 6 or a 7 hex for these 4 bits. Well, you can even convert part of them. يعني بس port A0 هو analog والباقيين digital والvoltage references زي ما هم. You can أو external في هذه الحالة or all of them digital and this one is analog والvoltage references هم voltage source and of the microcontroller. So we have a variety of options we can do using these 4 bits. تمام؟ وهذا البت حكينا عنه we use it to with the other two in ADCon 0 to select the clock speed, the conversion speed. وفي the last bit اللي هو bit number 7, this is called the result format select bit. When we get a result of 10 bits, do we want to do a right justification or a left justification in the AD result high and AD result low? خليني اشرحها هاي بسرعه عشان بدي اروح على مثال بعدين. نروح على مثال ونخلص ونقرا فولتج. بدنا نعمل مالتي ميتر اليوم يا جماعه. فولت ميتر. We're gonna do a voltmeter. We're gonna write the code and build a voltmeter similar like this to do the function like this one. طيب. What was I talking about?
عن الjustified right والjustified left.
Yeah, thank you. Thank you. So we have a register called result ايش كان اسمها؟ volt
address result low high.
AD result high and low. Yes. AD analog digital يعني result low هاي 8 bit. في واحدة ثانية زيها AD result high and this is also 8 bit. Where are these present? Where high registers? They are in the data memory. If we look at our data sheet, do I still have the data sheet open? Let me open it real quick. الميموري data memory. Look at them. First, ADCON 0, ADCON 1. وينهم؟ Hi, ADCON 0. Hi, ADCON 0, ADCON 1. These, the ones we saw a second ago, where we do the results. بعدين في result registers. AD result high, هيها. AD result low. تمام؟ 2 registers in the data memory. And we know that the result is how many bits? 10 bits. لأنه ال AT تاعنا A to D تاعنا is 10 bit A to D. تمام? We know it. Did I say that? Maybe not. Hey جماعة, the A to D we have for this in the 16F877A controller is a 10-bit A to D. طيب في microcontrollers ال A to D تاعهم 8-bit, and there are some microcontrollers have 8-bit A to Ds and 10-bit A to Ds, and you write in your code, you choose, I want to go with the 8-bit or the 10-bit. In our microcontroller here, it's only 10-bit, okay? Okay. So when we get the 10-bit, let me write in black. How do you want these 10 bits to be stored? The lower 8-bit in result low and the higher 8-bit, يعني هذا 10-bit result. If we pick to choose them like this, يعني the lower 8 in the result low register and 2 bits اللي ظلوا بالhigh register, هاي اسمها right justified. The result. If I pick to do them left justified, يعني the higher 8-bit will be here and في 2 bits lower راح يكونوا on the left, in the low. هاي بالأزرق. 10-bit result. And this case we call it left justified. ليش هالعجقة؟ الديفولت لهاي البيتس، لهذا البيت is what? 0. The default is 0. So left justified. The default is just left justified. طيب. هلا if I want to make this bit 1, يعني I will need to go write an instruction and set this bit, صح? It's going to cost me. It's going to cost me time. We agree on that, صح? So this is the default. هلا if you are reading a voltage that is between 0 and 5000 millivolts, ال A to D تاعك 10 bit بيعطيك readings from 0 to 1023. Each step here is 4.88 millivolts, right? Agree?
Yes.
Agree. So if my 10 bits result هذا اللي طلع هون هو الديفولت تاعه left، طلع مثلا 10 bits، say 1 2 3 4 1 2 3 4 1 2. ماشي؟ If I'm doing left justified, then I'm taking these 8 هذول بالresult high، صح؟ وهذول بالAD result low. تمام؟ In some applications يا جماعة ممكن تاخذ هذول زي ما هم and without reading this you can save another instruction here. شوف what you saved. You saved not setting that bit and keeping this at high and not reading these يعني ignoring them, and you can pretend they're 0 without hurting your reading. يعني the maximum, this يعني difference here, هذول ممكن يكونوا 0 0 up to the maximum 1 1 صح؟ If each step يعني 0 0 0 1 1 0 1 1 كل step is how much? .88 millivolts صح؟ يعني إذا عندي error كانوا 1 1 وأنا طنشت ال 1 1 اعتبرتهم 0 0. The max error, the maximum error here, worst case is what? 4 ضرب 4.88 millivolts صح؟ And this is a number less than 20 millivolts that you can ignore probably. Got the point? So if I leave them left justified, I don't care about 10 millivolt, 20 millivolt, 50 millivolt. I don't care about them. Just keep them 10 left justified and take the most 8 significant bit and deal with them. But if you want the 10 bits full resolution, you can do right justified. Well, you cannot ignore them. You can probably not ignore them. Take them and concatenate them. أو اعمل right justification وخذ الموست 2 مع lower 2 concatenate them. Okay. المهم. And I think this is the last thing we need to know here before we write our first program. Let me talk about the timing for a second. طيب, how to switch on. قلنا في هذا البت on AD on. Then we select the channels. And he's describing what we do. Switch on, set the clock speed, configure what channels we want to read and the voltage references, start conversion, wait for the flag to be done, format the result and get the result. But then do the math to compute what was the voltage, what outside. تمام? And this is explaining the details. Talking about the conversion speed. I don't want to go into a lot of details here. بس general هيك يعني rules. The time it takes the ADC has a clock. The analog digital converter has a clock. The clock has a frequency, and we decide this frequency over here. شايفينها? It's a prescaler of the oscillator frequency. تمام? For a full 10-bit conversion, we need time that is equivalent to 12 time periods of this clock. Okay? The minimum clock period for a correct operation, taking in mind what we talked about here, I'm gonna get something here not accurate or something acceptable or something very accurate, is something equal a clock period to 1.6 microseconds. Time this by 12, this is equivalent to 19.2 microseconds. ماشي? So you need a clock faster than this. It's going to be too fast, صح? It's going to be too fast. Faster than this, it will be too fast. And you will not get the accuracy. So this translates into 625 kilohertz. So anything below 625 kilohertz is something that is acceptable. تمام? So we're gonna aim something شيء حوالي 500 kilohertz. Just make. لأنه إحنا our clock has 8 meg. So if we go write our program, divide the 8 meg على oscillator clock 16. Yeah, we'll get 500 kilohertz. صح؟ إذا الأوسيليتر clock تاعتنا equals 8 megahertz على 16 يساوي نص megahertz 500 kilohertz. Yes. Okay. This is so احنا هذول البيتس we want to set them like this. تمام؟ وبعدين ترتيب registers, everything is all good. Okay, go done. Okay, when we say go, we wait for this same bit we wrote to become back a 0, or we look for an interrupt flag. we can wait it, do pulling while this is not equal to 1, keep waiting, or we can enable the interrupt and deal with the result when we're sent to the interrupt service routine. طيب, formatting the results left and right, I talked about it. هيهم. This is right justification, this is left justification. The default is left justification. You can ignore the lower 2 bits if you don't care about this error of 4 steps, or you can do right justification and concatenate. Even in this case, you can also do concatenation. تمام. هلا when you say go get me a reading from the sensor on port A0, before the next time you can get another reading, you need to wait for 2 time periods of the A to D. Okay, and this was 1.6 microseconds times 2 يعني 3.2 microseconds. Okay, يعني بين reading والreading is 3.2 microseconds, which is really fast, صح? In applications like trolling, يعني in our applications really fast. هسا taking the amount of conversion we saw زائد هاي الوقت يعني the best possible conversion time is 28.5 microseconds, which means the maximum sampling rate we can work on 30 kilohertz. يعني عندك signal برا and you can read 30,000 samples in a second. Is that acceptable? Well, for a 16F877A controller, $2 controller with a data acquisition system, this is very nice. يعني there are some data acquisition systems you buy them for $100 لحاله data acquisition system. بدك في هاي الحالة يعني ال A2Ds are 12 and above, hundreds of thousands or maybe millions of samples a second. طيب, resolution 10 bit. بعدين نيجي على ال manipulation. Well, you know what? Let me talk about manipulation now. ولا جوا الكود. طيب, option. أنا كاتب لكم هون شوية كودات بصراحة. Do you want to write them from scratch ولا just take them and نمشي عليهم إذا طفيتوا؟ I can take as a sample if you want. مثلا voltmeter هذا و run it on the board وأمشي معكم خطوة خطوة. Or do you like to write them from scratch? حد يتطوع.
زي ما بدك دكتور.
والله أنا زي ما بدكم الساعة أنا عادي بسهر معكم للصبح. طيب, let's try this. أنا المهندس جواد he advised me that this is faster بصراحة. That's why أضفتهم على السلايد. Let's try this. شو رأيكم؟
Okay.
هذا code that I'm gonna go take to micro C, and we want to connect the voltage level على analog pin 0, port A0, and we want to convert that into a number and display it on the 7-segment display. شو رأيكم؟
تمام.
يعني شو راح أعمل voltmeter. I'm gonna do a voltmeter. Connect the voltage and display the number on the 7-segment display. But I'm gonna do it on my board. So if you are able to recognize what's the voltage outside, the voltage can come from a battery, can come from a potentiometer, can come from a sensor, it can come from anywhere. أنت بالنسبة لك, so now we don't care what kind of sensor we're dealing with, صح? Temperature sensor, humidity sensor, it's all a voltage. يعني بالنسبة لنا when we write our embedded assembly code, we're dealing with a voltage inside the program. طيب, the voltage, how does it translate into temperature? Well, this is what we're going to talk about in chapter 8 that we will cover يعني maybe Tuesday in the normal lecture. يعني how to, بس خليني أفرجيكم إياها real quick. when we talk about sensors, there's a place here like مثلا هذا temperature sensor. See, this is a snapshot from the temperature sensor data sheet, and it gives you an equation. If you have the voltage, you can compute the temperature. So all what we care now about in this data acquisition is to get to know the voltage. Then we can convert it into a temperature, we can convert it into humidity, you can convert it into distance, into whatever. Okay? طيب. So let's start a new project. تخيلوا احنا صار لنا ساعتين تقريبا. If I am to do this in a normal half an hour ولا 40 minutes minus lecture بدنا 2 weeks صح؟ Okay. So I'll call this.
دكتور المحاضرة هيك أحسن من الصبح.
والله؟
يعني ممتعة أكتر، أطول، هديك
حلو.
بسرعة بتخلص.
يا أنا ما بحبش بخلص بسرعة، لازم أطول، بظل أشياء واحد بيربط الأمور كلها مع بعض صح؟
إنه بنركز بالضبط.
طيب. كلاس ديمو 8 فولت ميتر، شو رأيكم؟ يعني بمعنى آخر A to D. A to D. Okay. Next. Finish. Control A, Control V. Listen. What am I gonna do? شوف خلينا قبل نطلع على الكود، شو اللي بدنا نعمله احنا؟ We want to configure the analog voltage. You know what? خليني stop share. Let me show you on the board what I want to do. بعدين نيجي هون. Let me show you on the board. بعدين نيجي على الكود عشان نعرف شو بدنا نعمل، شو البرنامج تاعنا. Let me go switch to that other camera. Do you see my board?
Yes.
Yes.
Okay. طيب قبل ما نبلش. Do you know what this is? وين ايدي انا؟ هي. Do you know what this is?
potentiometer.
You know how a potentiometer works?
Yes.
مقاومة صح؟ هو مقاومة متغيرة صح؟ له 3 صح؟ 3 pins. So شو أنا راح أسوي؟ راح أجيب البوتنشيومتر هذا. خليني أرجع بس back to the screen عشان show you what I'm gonna do. I'm gonna go get a potentiometer. This is what we're gonna do. وpretend البوتنشيومتر في هاي الحالة is the sensor صح؟ So potentiometer صاير خام بالرسم أنا. Okay. It's a resistor. A variable resistor بالنهاية صح؟ نوصلها على 5 فولت and I get a V out from here صح؟ حسب ما بلف هاي البوتنشيومتر. So I connect this هاي البنز الفوق والتحت على 5 فولت والجراوند، والبالنص باخذه على port A على الانالوج port. تمام؟ بس بصير ألف بتصير هاي الفاليو تتحرك بين الصفر والخمسة صح؟ وأنا I want to know هلا هاي potentiometer ولا analog temperature sensor ولا humidity sensor ولا IR sensor. We don't care صح؟ It's a voltage. بس أعرف الفولتج بستخدم الفورمولا الداتا شيت بحوله لتمبريتشر ولا لهيوميديتي ولا لديستنس. Okay? So this is what I'm gonna do. So هذا البوتنشيومتر بدي أجيب voltage source زي البطارية هذه تاعتي. هذه الفولتج بتعطي من 0 ل 9، بس أنا ال A to D تاعي اللي على المايكرو كنترولر بستخدم الباور سورس تاع انا يعني اخليهم زي ما هم، بقدر اجيب له فولتج ريفرنس هاي ولو براني، او بستخدمه اللي موجود بالمايكرو كنترولر نفسه اللي هو من 0 ل 5 نفس الفولتج سورس. في هاي الحاله بوصله على 0 و5 وانا عندي بنز هون، يعني عندي هون بن لفولتج يعني خليني اقرب بس شايفين يعني هون هاي جراوند هاي VCC. بقدر اوصل هذول التو بينز على التو على البوتنشيومتر these two pins، واخذ هذا الفولتج واخذه على بورت A0 اللي هو انالوج 0. تمام وخلاص. وبعدين هاي 7 سيجمنت ديسبلاي مش شايفينها انتم؟ شايفين طرفها شكلكم هيك شوي ازيحها هيك. في عندي 2 7 سيجمنت ديسبلاي هون شايفينها؟
باينين.
بدي اطلع عليهم رقم. هلا the 7 segment displays I'm gonna explain how to use them بالnormal class in chapter 8. اوكي؟ موافقين؟ اوكي. طيب هلا I'm not actually gonna bother myself واجيب السلاك هاي واوصل الى اخره. هذول الجماعه these guys who made this board have several potentiometers here. شايفينهم؟ اعطيني potentiometer هون، potentiometer هون، potentiometer هون. See them?
Yes.
I have several potentiometers. طيب هلا شو سويت انا؟
دكتور راحت.
راحت. طفى الكاميرا. ليش؟ it's back. Okay. So the board has several potentiometers here. شايفينه؟
Yes.
هلا هذا البوتنشيومتر this one you see it؟
Yes.
وهذا البوتنشيومتر مكتوب عندهم ADC input، يعني اوريدي موصلين لي اياهم على البورد، بدل ما انا اغلب حالي واجيب هذا واصير اوصل سلاك برانيه. I'm gonna use these potentiometers the same concept. تمام؟ وبالجمبر هذا بقول له الاوتبوت تاعهم حطه على بورت A0 ولا بورت A1 ولا بورت A2. هون في جمبرز. اوكي؟ سو انا بدي اخذهم على بورت A0. طيب انا حطيت الجمبر كاني وصلت البوتنشيومتر هذا البراني تاعي على بورت A0 والفولتج هاي واللو تاعهم من الخمسه والزيرو تاعت الفولتج سورس تاعت المايكرو كنترولر. اوكي this is what I'm gonna do. وبعدين اصير الف هذا الفولتج، الف بتغير الفولتج اللي جاي على المايكرو كنترولر، بتغير الفولتج اللي جاي على المايكرو كنترولر، بتغير الرقم 10 بت رقم من 0 ل 1023، وهذا الرقم 0 ل 1023 بدي اطلعه على بن على بورت. اوكي بطلعه على بورت اول وبعدين بحوله ل 7 سيجمنت نمبر. شوفوا على 7 سيجمنت ديسبلاي عشان يكون مور فريندلي يعني. طيب let's go back to our code here. So what we're gonna do in our code يعني this first line عشان 7 segment. اوكي انتوا تعاملتوا مع 7 segment بحياتكم؟ اكيد صح؟
Yes.
يعني it's something يعني 7 segment display. شوف يعني لو بدي اكتب صفر، شايفين لو بدي اكتب صفر 0
بدو كلهم الا جي
0. لو بدي اكتب 0 ليش مش راضي يكتب؟ شو بسوي هذا؟ يعني حتى اكتب 0 يعني ممكن اشرحها بعدين ولا هي راح اشرحها في شابتر 8 والله يعني حرام اشرحها مرتين. اوكي بس 3F هاي مثلا 3F is something like كان اكتب 0 هون. لو اكتب 3F ليش ما برد علي؟ 3F 3 ليش بكتبش؟ طيب اوكي I don't know ليش مش راضي يغير. anyways يعني 3F صفر راح يطلع شكل صفر 061 5B2. Okay I'll explain this chapter. ماشي. The main two things I want to do is write two functions. Function called initialize the analog digital converter يعني initialize it يعني pick the channel, set the conversion speed, tell me how the result is going to be right justified ولا left justified and so on. وبعدين لما بدي اقرا الفولتج when I want to read the voltage on the pin I just say read. Okay this is the only thing I want to do. يعني two functions. طيب so let me go to the do functions بعدين I'll look at the details الثانية. so وبعدين these بقدر اكتبهم جوا المين هيك ويكون يعني معفشك بس انا كاتبهم as I wrote them like functions so you can use them. It will be easy for you to use them more practical. so AD con 0 كتبت فيها 49 is what لو اروح على if I go to AD con 0 where is AD con 0 هاي AD con 0 فرجيكم شو سوينا هاي AD con 0 let me just up 49 صح يعني 49 يعني 0 كويس الخط 0 1 0 0 بعدين ال 9 is 1 0 0 1 صح what did I do here I turned on oops شو اللي صار okay I turned on the power صح 1 I turned the power on for the microcontroller I didn't say ما قلت له go أنا بعمل initialization right now بس بدي أقول له read بقول له go بعدين I selected channel إيش 001 يعني select channel 1 analog 1 اللي هي إيش analog 1 اللي هي shared مع port A1 اللي هو البن اللي أنا I'm gonna pick over here on the 7 segment display على البورد طيب أوكي بعدين هذه 1 0 يعني أيها 1 0 1 0 يعني يا اوسيليتر 8 يا اوسيليتر 16 على 16 صح؟ ديبند على البت الأخير سو هذول 0 1 تمام؟ أنا بالكونفجريشن ريجستر الثاني هاي عاملها 0 أو 1 عاملها 1 I think 1 فأم picking 16 عشان أصير ليش 16 لأنه أنا عندي my oscillator clock equals 8 megahertz صح if I divide this by 16 يساوي 500 كيلو هرتز وهذا complies with the recommendation تاع محطوطة بالداتا شيت إنه below 600 كيلو هرتز وين راحت؟ I showed it to you guys صح؟ المهم طيب وهي AD con 0 هاي AD con 0 49 بعدين AD con 1 شو C0 خلينا نشوفها C0 is هاي AD con 1 عملناها هاي AD con 1 C0 C0 is C is what? 1 1 0 0 0 0 0 0 صح؟ هاي C هاي 0 So عملت right justified the result وهاي 1 تاعت الكلوك select هاي عملتها 1 وكانت هناك بالأول 0 1 so I divided by 16 conversion هذول كلهم zeros يعني ايش؟ كل الشانلز عملتهم انالوج والفولتج ريفرنس هم الفولتج سورس تاع المايكرو كنترولر كل الشانلز تاع بورت A و E انالوج تمام let's go back to the code وبورت A شو عملته؟ FF يعني input لانه signals are gonna عشان to enable buffers اوكي لازم يكون input هذا الفانكشن that will initialize the A to D في فانكشن ثاني that will read the A to D شو بيسوي هذا الفانكشن في الجو done bit ذاكرينه الجو done bit اللي هو this one هذا this one هذا قلنا you write a one فيه it will do go يعني ايش it will start the successive example hold successive approximation وتبلش تجهز لي بال 10 bits 10 bits ما بصير هيك on the fly it will take time when the result is ready the one that I wrote here will turn back into zero فبضل استنى فيها ترجع back to zero okay حتى اغير هذا البت to make this bit touching anything else what can I do I can OR everything with zeros except this bit صح so I can OR AD can 1 with 0 0 1 0 0 0 0 0 هاي ايش اللي كتبته انا 0 4 ماشي 1 0 0 is 1 0 0 1 0 0 is 4 اوكي تمام
So
good to go
once انه نادي هذا الفانكشن راح
start conversion راح يعطيك قراءة بس استنى يعني once I call this function I'm gonna get a reading بس in details I set this bit I said go بعدين بقول له while AD كان 0 ANDed مع 0 4 يعني I masked everything وظلت طلعت bit اللي عملته 1 ANDed كل شيء مع صفر طلعش عليهم صفرهم غير هذا البت مع 1 هو 1 لاني كتبت 1 is gonna stay 1 so هذا الكونديشن is gonna stay true واظل stuck here شايف انا حاط سيمي كولن هون هذا الكونديشن will stay true and I'm gonna be stuck بهذا السطر in this line until this bit اللي هو can go goes back to 0 يعني done يعني الconversion is done then I can read the result clear طيب the result I want to return it أنا قلت له الفانكشن A to D تاعي هاي البروتوتايب تاعه هيو I'm not gonna pass anything بس I'm gonna return an unsigned integer ليش مش unsigned character لأنه I want to return 10 bit الكاركتر 8 bit صح فمضطر على 10 على الانتجر so I'm gonna return an unsigned integer 16 بت طيب هذول 16 بت اللي بدي ارجعهم الجواب الريدنج هم ايش هم الاي دي ريزلت هاي انشفت الى اليسار 8 مرات انا عملت justification right justified صح الريزلت تاعي عملته right justified اذا تتذكروا يعني هون فالريزلت ريجستر هاي بدي اشفتها right justified yes I did فها بدي اعمل هاي شفت 8 مرات على اليسار وهذول البت اخذهم زي ما هم واعملهم concatenation بالانتجر شايف انا I'm returning an integer here ف I take result register هاي زي ما هي شفتها لليسار 8 مرات يعني وبعدين هاي or يعني concatenate الثمانية بتس اللي تحت صار عندي 16 بت مرتبين اللي هم اللور 10 بتس منهم هم ال 10 بتس تاعت الريدنج اوكي I'll return them لهم return is this clear
Yes,
guys
بصير آخر خطوة بس كمان مرة
ايش قيس
آخر خطوة بس هي هاي تبعت الشيفت كمان مرة
طيب قيس انا عندي الجواب اللور 8 بت انا الجواب is 10 bit right the result is 10 bit اللور ب 8 بت بالريزلت لو صح بالاي دي ريزلت لو والهاير 2 بتس بالريزلت هاي صح بالريزلت هاي here هون يعني الريزلت هاي بعدين result low result high أنا عملت right justification right justify صح؟ so أنا عندي 10 bits ال 10 bits راح يكونوا هون 1 2 3 4 5 6 7 8 9 10 okay so I want these 8 و these 2 بس بدي أحطهم بانتجر integer x فx شو راح يسوي؟ شو راح يكون x؟ هو هذا بقدرش اعمل له يعني انا بالنهايه انا عندي 1 2 3 4 هذول راح يكونوا زيرو صح؟ you don't care بس هم 8 بت 4 5 6 7 8 هاي ريزلت هاي وهاي ريزلت لو كمان 1 2 3 4 5 6 7 8. How are you going to put them in X? بدي اخذ هذول shift them left 8 times to the left. بصيروا هيك. شو بصير بعد الشيفت؟ بصيروا الفوق هذول 1 2 3 4 1 2 3 4 والهاي ريزلت هاي، واللو راح يظلوا زي ما هم 1 2 3 4 1 2 3 4. هلا بعمل اور بيناتهم، فهذول اور هذه راح تكون زيروز صح؟ هاي راح تكون زيروز، فهذول راح ينزلوا زي ما هم here، هذول راح ينزلوا زي ما هم، فبصير عندي كأني حطيتهم جنب بعض بإكس. عملت إكس 16 بت. Is it clear ولا لسه؟
يس واضحة.
لأنه يعني هذا ريجستر، هذا ريجستر. I want to return an integer. An integer is 16 bit، خلص متكامل مش مفصول. So I took the higher 8 bit اللي هم result high shifted them 8 places عشان أقدر أعمل 8 or مع ال 8 الثاني ويصيروا جنب بعض concatenated. طيب خلص هاي الفانكشنز. هلا احنا is the application. What do we want to do? What do we want to do? هاي المين بروجرام. بورت بي وسي ودي اعملهم اوتبوت عشان اطلع عليهم ريزلتس. خلص ماشي. بعدين الفانكشن ذات اي روت ناديته. طبعا هون قلت له ATD init initialize the ATD، يعني set الكلاك تاعه الجواب بسوي اعمل له رايت justified read channel 1 صح؟ بعدين I didn't read. هون لما قلت له ATD read what did I do؟ رحت قلت له go واستنى الجواب تاعي يجهز ورجع لي 16 بت. The reading I get رجعها وحطها بمكان اسمه my reading أنا معرفه defined here called my reading 16 بت. تمام. So what do I have here؟ لو كان الفولتج على البن 5 فولت، شو الماي ريدنج راح تكون قيمتها؟ 1023 صح؟
يس.
إذا الفولتج كان 2.5 فولت، شو الماي ريدنج راح تكون قيمتها؟
512.
يس 512 مظبوط. تمام. So my reading متفقين عليها it's a 10 bit number. It's a number value between 0 and 1023. هلا in this program هيني قاعد اطلع لك اياها زي ما هي my reading فرجيني اياها بورت بي. طيب اللور 8 bit والهاير 8 bit منها فرجيني اياها بورت سي. my reading هي 16 bit، شفتها 8 على اليمين shift right times to the 8 times to the right عشان اخذ الهاير 8 bit وفرجيني اطلعهم على بورت سي. هاي for you guys just to see them. واضحه؟ لانه my reading is 16 bit I cannot show it on all on port B صح؟ لانه port B it's only 8 bit وport C 8 bit. So I say my reading put it on port B, it's going to take the lower 8 bit from my reading put it on port B. هي عشان for us to see it. In real applications you don't need to do that. You just take my reading and do math and compute temperature. واضح؟ بعدين my reading shifted to the right 8 times عشان اخذ ال higher 8 bit and display them on port C. تمام؟
Yes.
Yes.
Okay, great. طيب هلا this reading, this number from 0 to 1023 is actually representing a voltage صح؟ It's representing a voltage between 0 and 5. ليش ما نحوله لفولتج ونشوف رقم هيك voltage؟ So how do I do that? I have a number x between 0 and 1023 and these represent 0 volt to 5000 volt to 5 volt. خلص 5 volt. كيف أحوله؟ If I know x, what is the voltage on the pin? The voltage on the pin is equal to the reading that I read هاي x صح اللي هي my reading هاي x اللي هي my reading بالكود اللي أنا سميتها my reading اللي عملتها هاي my reading اللي أخذتها من A to D read اوكي I know this بعرفها طب بس شو الفولتج برا my reading هي نسبة من 1023 صح بدي احولها لرقم من 0 ل 5 فولت ضرب 5 فولت صح right
yes
رايس طيب يا جماعة هون في نقطة بدي تركزوا لي عليها because when you go really work in the microcontroller some of you are gonna find some problems and remember me in the lab what's better to say high voltage V equals my reading divided أنا بدي أكتب كود صح divided by 1023 then this is multiplied by 5 or V equals my reading times 5 then this is divided by 1023 شو أحسن ولا ما بتفرق what's the right thing to do
نقسم أول
why يا صالح
عشان ما يصير overflow
مشان ما يصير overflow can you elaborate more
إنه لو ضربنا ب5 ممكن يطلع خارج ال 10 bits فما يقدر يوسع أو whatever the sizes فإذا قسمنا بصغر العدد it's because of that.
Well, with casting you can override this problem, right? Let's imagine, okay, that's correct. But there is a more serious problem.
جزء الاكيرسي بالفلوتينج لما نقسم لما نضرب انه عدد الارقام بعد الفاصله انه اذا قسمنا او ضربنا راح تفرق معي مين بضرب بالاول.
Okay, you mentioned فاصله floating points, huh?
Yes.
What are we dealing with here? We're dealing with memory locations with integers and characters. Did you notice a data type here called float? It's all integer and this is called integer math. In integer math, what happens here? integer math.
الفاصله راح ينسى
شاهد
يعني يمكن يعني احنا لانه هلا it's an integer division فممكن تختلف قيمة الرقم يعني من بالحالتين حتختلف حسب يعني إذا مثلا ما بيقسم الرقم على 1023 سو إحنا قطعنا نص يعني قطعنا جزء من الرقم بعدين ضربناه ب5
يس قطعتي جزء كبير بس مش بس جزء guys ركزوا معي هاي let's take هاي غلط بس ليش هي mathematical صح بس if we write the code this way my reading هي رقم between 0 و 1023 صح right my reading
Yes.
so it's all the time it's less than 1023 صح except غير لما يصير 1023 صح so my reading divided by 1023 is going to be always 0 except لما تكون my reading equals 1023 because if افرض هاي 512 divided by 1023 is what 0.5 صح
Yeah.
بس an integer cannot be 0.5 it's an integer صح so it's going to be rounded to 0 بعدين 0 times 5 0 so the voltage here you're going to get is going to be always 0 and غير مرة واحدة when this is 1023 divided by 1023 1 times 1 5 So you're going to be able to know if the voltage is 5 and everything else is going to be 0. فاهمين علي? While in this case, I multiplied my reading by 5. So there are 5 places I'm going to be more than 1023 without fractions or above fractions. So I'm going to be able to know when this is 1023, I'm gonna get the 1 صح تقسيم. I'm gonna know لما تكون divide. I got 5 divisions of my reading صح يعني ضربتها 5. So my reading إذا كانت 512 512 in this case it's going to be 0, but 512 times 5 in integer math I'm going to go to the programmers. 512 divided by 1023 is what? 0. This is how the computer works. Okay, بس لو قلت له 512 طبعا 0 times 5 is 0, بس لو قلت له 512 times 5 equals that divided by 1023, okay, it's 2. While it's 2.5, but we lost the 0.5. فاهمين علي?
Yes.
Okay, great. So it's important how you write your thing. If you need more accuracy, well, اعمل ضرب 50. You'll get like 5.1, 5.2, 5.3 صح؟ You'll get يعني اضرب ضرب 5000. You get this voltage in millivolts. You'll get more accuracy. Okay. طيب. ماشي? So it is different writing this in this way with integer math is not the same as dividing this by 1023 بعدين multiplying everything by 0 by 5. It's not equal, not the same. صح? It's not the same because this part is always going to be 0, except at one point when my reading is actually equal to 1023. The division will be 1 times 5, it will be 5. Got it, guys? طيب. So here the result of this, my number between 0 and 5. صح? My reading was a number between number between 0 and 1023, right? But here, the voltage, my voltage will be a number between 0 and 5. صح؟ بالنسبة لنا volts, right? بس لو ضربت هاي ب5000 it will be between 0 and 5000 millivolts, right? It's up to you how to deal with it. طيب. And now this, my voltage, بقدر اطلعه على port زي ما هو يعني راح يطلع لي ال5 is gonna be 1010 صح؟ بس I'm using this my 7 segment map. If it was 5, and if it was 0, I'm gonna return 3F, which will show me a 0 on the 7 segment. If my voltage was 1, I'm gonna return this element, right? 0.6, which will show a 1 on the 7 segment display. Got it? إذا كانت 5 volts، والله أنا ما عارف ليش هذا مش قادر أغيره. I don't know, whatever. Okay, so I'm gonna show a voltage here, but then I did the delay before the next time I go back and read. I don't have to do 500 millisecond delay, but this is for visualization because less than half a second يعني you'll see the numbers jumping real quick إذا في noise صح إذا voltage. So a reasonable amount of delay, but there is a minimum that has to be there is what? The 3.2 microseconds. Okay. This is the program. Let's program it. Let's program it. Build. And program. Then I'll switch my camera. It's programming. Oh my god, ساعتين ونص الله لا يطرز لكم منو اللي اخترع. Okay, I'm gonna stop sharing, switch the camera and see what we have over there. Where is the camera? Okay. Okay, let's see what we have. أيوة. So we said we are using AN1, analog to digital converter 1. I connected AN1 here on this potentiometer, and I want to start moving it, turning it right and left. Sure. Okay. See, there's something going on. شو شايفين؟ شوف remember I read خلاص هيك nothing. شوف my reading أنا قلت له display the lower 8 bit on port B and the higher 8 bit on port C. What do I have now؟ يعني 10 bits تاعيني شوف هذا قاعد بطفي وبضوي يعني it could be 1 0 something in the middle يعني افرض انه 1 0 0 0 0 0 0 0 0 صح؟ Which means the voltage on analog pin 0 is something between 0 and 0.4 and 4 millivolts يعني شيء negligible. هاي قاعد شو اسمه jumpy. If I start turning the potentiometer, I'm turning it a little bit. Who can tell me what's the voltage now? 1
احنا مش شايفين
يعني هاي مش شايفين ال LEDs؟ لا شايفين يا مالك. ايوه what are you جايات فوق. ايوه الفوق. port B. شايفين port B؟
Yes.
port B. See port B when انا يعني the potentiometer انا قاعد بلف هسه انت بطلت تشوف البوتنشيومتر. هيك. اوكي. طيب. Look at the potentiometer. هذا أنا لافه على الأخير يعني the voltage is هاي lower 8 bit برضو مش شايفه بعدين مع السلالة هيك. Okay. Trouble. Clumsy. طيب. Here. I port. What do you see? Port B. B مش مبين.
شوي لفوق.
هيك البورد أسهل من الكاميرا. هيك شفتوا صح؟ هلا my potentiometer لاف على الأخير على lowest. شوف هذا. So the lower 8 bit are on port B. هيهم. يعني we're almost zero صح؟ البت هذا قاعد بيطلع وبينزل هيك جمبي يعني زي حتى أنا صاحبه هاي لا خلوا. شايفين؟ The voltage is almost zero. إذا إنه 1 يعني هذه لما تكون 1 it's like 0.4 millivolts يعني هذول 2 bits قديش مع بعض بيأثروا lower 2 bits 20 millivolts maximum صح؟ هلا I'm gonna start turning this to the right يعني higher voltage. هلا 20 millivolt تقريبا عندي. هلا هاي قاعد بزيد الرقم شايفين؟ The 10 bits are incrementing. الفولتج ناو قديش بقدر لو اسالكم سؤال قديش الفولتج ناو 0 1 1 1 صح يعني هذه قديش 0 1 1 1 ال 10 بيتس تاعت ال 10 بيتس تاعت الماي ريدنج يعني هذه E صح؟
70 ملي فولت
بالضبط E ضرب 4.8 ملي فولت بيطلع عندك صح الحساب.
70 ملي فولت.
increment so keep incrementing لحد اخر شيء على اليمين. انا هاي الماكس تاعي شو وصلت؟ هاي الماكسيمم فولتج اللي وصلته. I got these two on. شايفين هذول port C. Port C these are the most يعني 10 bits most two significant bits. هذول اثقل شيء. هاي so the 10 bits are 1 1 1 1 I don't know هاي ليش 0 0 1 1 0 1 1 هاي الفولتج تاعي. بجوز انا مش واصل ل5 يعني انا لو اجيب المالتي ميتر اكيد انا مش واصل ل5. والله I'm gonna try it. وبعدين if you see the 7 segment display I'm displaying on هيها ايوه اوكي طيب ضيعنا again. Okay. It's better to slide the board. Okay. شو شايفين انتوا رقم ايش؟ 7 segment 4 صح؟ If I turn it to the left قاعد بنزل بس انا مش قاعد اشوف. هلا صارت 3 صح؟ 2 1 0 اوكي؟ طيب لو اجيب المالتي ميتر تاعي طبعا I have a more accurate one اللي هو الدمو الثاني بس خلينا بسرعه نشوف الفولتج. طبعا مش واصل 5 ما واصل 5 it's not at 5 volts. is it accurate? let me measure the voltage. طيب شو رايكم انا اجيب هذا واجيب ال 5 فولت من برا عشان نشوف 5. هاي قيمه الجمبر. so I'm not gonna take the voltage من البوتنشيومتر. بدي اروح اجيب سلك. I'm gonna get a wire and connect it directly to the voltage source. Where the voltage source? هاي VCC. I'm gonna connect it to port A1. When port A1? Port A0 port A1. بدي pin لport A1. هاي على اليمين. شو شفتوا؟ شو شايفين؟
5 بالضبط.
5 صح؟ 5 لأن أنا وصلت على الفي سي سي فالبوتنشيومتر شكله فيه مقاومة مش قادر أوصل الماكسيموم. هاي 5 أوكي؟ لو أحط عليه جراوند هاي الجراوند أوكي؟ كلهم طفوا شايفين؟ ال LEDs. هلا ليش مش طالعة على الديسبلاي؟ لأنه أنا مش enabled بصراحة. نزلت low. I need to fix it. I need to rise high to high. Okay. المهم I'm gonna put back the high يعني مش واصل لل5 فأنت you can get the volt. أنا ما حطيتش الفولت ميتر تاعي. هسا هيك 4 الفولتج على port A0. لو أجيب هاي ground I hope إنه هذا ما استخدمت المالتي ميتر على port A1 sorry. اوكي شكله مش ظابط. في جزء بالبطارية طافي فيه ما بصير شو ماله. anyways بس على السريع let me go back to the more accurate. So I'm gonna save this one. Actually we saved it لأنه we built it. hide. Let me close it. Close the project. وجو جيت the last demo. هذا عملته more accurate the last demo. 2 digits. هذا. وبعدين استخدمت فيه interrupt to display ال values أكثر. يعني مش كل نص ثانية. So let me start a new project. And make class demo 12 voltmeter. Higher accuracy. Whatever. Okay. Let me show you the code. هون what I did is almost the same. بس the display شلتها من المين loop. وين حطيتها؟ I put it in the timer 0 interrupt every half a second. شايفين؟ بس بدل ما كنت أعمل delay قاعد بعمل الحكي بالانتربت بس. في شيء مش واضح هون؟ وبضرب I'm multiplying the reading by 50 بدل 50. ليش؟ عشان يصير عندي more accuracy. شفت أنا بلف it jumps من from 1 to 2 to 3 to 4 بس في بيناتهم أنا بزيد بالفولتج بس you're not seeing it صح؟ لأنه الأكيورسي 1 digit قاعد بدي أسويها 2 digit هون فضربته ب 50 يعني بصير يعني 0.1 0.2 1.1 1.2 فولت إلى آخره. أوكي؟ وحطيتها بالانتربت كل نص ثانية. وشوف شو عملت كمان. بدي أستخدم 2 7 segment displays. الرقم اللي هو my voltage I want to display باقي قسمته على 10 على 1 7 segment وقسمته على 10 على الاذر 7 segment يعني الكوشنت والريميندر. لو عندك رقم من 2 digits if you have a number of 2 digits افرض the number I read كان 512 صح؟ ضربته ب 50 على 1023 صح؟ I'm gonna get a number like مثلا 2 صح؟ هذا راح يطلع 25 صح؟ هاي نص ضرب 50 25. I want to display it as 2.5 على 2 7 segment. I want to display 5 على حال والاثنين لحال. كيف افصلهم؟ هاي الماي ريدنج قسمها على 10. شو الجواب؟ انتجر ماث. شو الجواب؟ 2 right؟ طيب الريميندر باقي قسمتها على 10 شو بيطلع؟ 5. فانا فصلت الخمسه لحال واثنين لحال. هاي بحطها على ديسبلاي 1 وهي على ديسبلاي 2. تمام؟ هلا الديسبلايز كيف استخدم الديسبلايز؟ بدي اعمل شيء اسمه تايم مالتيبلكسينج. هذا شيء راح اشرحه in chapter 8 in class. طيب بس هذا بما معنى يعني انا 7 سيجمنت ديسبلاي تاعتي اللي راح تشوفوها على الكاميرا فيها يعني مربوطه على بورت دي. بس اي شيء بتكتبوا على دي راح تطلع كل الديسبلايز. بس حتى اعمل يعني بصير بودي الاحاد على 7 سيجمنت ديسبلاي بعملها انيبل. بعدين خلال 4-5 ملي سكند بودي العشرات عليها وبعمل انيبل لل 7 سيجمنت الثاني وبطفي هذيك. وبعدين الاحاد بعدين العشرات احاد عشرات سويتشنج ريلي فاست. عينك ما بتشوف الفرق. اوكي هاي عشان to reduce the wiring. يعني this is a topic I'm going to explain in chapter 8 in class. تمام؟ So don't worry about it here. But this is what I'm doing. أنا هون قاعد على التايمر. لما تكون قيمة التايمر 20 هكس يعني كل 4 ملي سكند. We look at these numbers later. اعمل switch. اعمل enable لل 7 segment display الأولى لأنها enabled by port A. طلع لي باقي القسمة. وبعدين enable باقي الوقت 4 ملي سكند الثانية. وطلع لي العشرات. وهذه الفانكشنز نفسها. The 7 segments it's a part of chapter 8. I'll explain it in detail over there. programming, and this is the last thing. أنا خلاص. Okay. Well, I see some people ran away. شو شايفين؟ What am I reading? أنا شو الفولتج اللي قاعد بقراه هون؟ Port A0 ولا 1؟ والله I forgot بصراحة. Maybe 0. شايفين هيك الفولتج 0 شايفينه؟ هيك. 0 يعني imagine لو إن أنا عامل 7 segment وضويت الدوت هاي الديسيمال بوينت هاي كان تشوف 0.0 صح؟ بصير أزيد 0.3 0.4 0.5 6 7 8 9 هاي ignore it ماشي بس طلع almost 2 هاي 1 1.1 1.2 1.3 1.4 اوكي up to 4.8 لما كنت 1.7 segment display مفرجيه كان فرجيني 4 ما كان فرجيني 0.8 اوكي تمام يا جماعه هسه هذا الفولتج that I am getting from the potentiometer you can get it from a battery شوف لو اجيب البطاريه هاي لو اجيب البطاريه هاي بطاريتي 9 فولت شو راح تسوي؟ هي شغاله بدي احطها I'm gonna remove هاي ال A to D صار floating بدي اجي اجيب ground على port A0 هي هاي ground هاي port A0 جبت بطاريه شو شايفين 5 صح؟ 5 معناها هي 9 فساتوريت 5 ترى انا الاضاءه هون شكلها مش ضابط شوف هيك احسن صارت صح؟
يس
اوكي بس عملت ادجست لحالها I don't know why شايف؟ فلو احط هاي البطاريه تاعتي اللي هي 9 فولت باتري 5 عملت ادجست والله ما انا عارف هي ذكيه زياده عن اللزوم. Anyways you can try to simulate it. I hope this was useful بس يعني in general the voltage we were able to read today and display the main purpose of it is to be able to read it and translate it to temperature translate it into humidity translate it اضربها بفورمولا انا ضربتها ب5 او 50 وقسمتها to made it voltage هلا الفولتج تدخله على another formula تعملها temperature وتقول if temperature اكثر من 20 Celsius turn on the air condition if it's less turn on the I don't know the heater whatever تمام any questions I'm going to stop the recording if you don't mind and I finished I'm lecturing this and I'm not going to upload this today I'll leave it to